talk about transforming exponential graphs. So you might recognize some letters here that we've seen before. A stretches or compresses our graph. H moves our graph left or right, the opposite direction of the sign, which is why there's a negative there. And then K moves our graph up and down. And of course, we already just got done learning about B. B is what creates the shape of our graph as an exponential going up if it's growth, down if it's decay, depending on what the value of B is. All right, let's write some of this down. You might have already seen this in the notes that I wrote, but A is the vertical stretch. If A is greater than 1, I'm going to ignore A being negative at the moment. And it's going to be a vertical compression, so it makes it shorter. If A is less than 1. Okay, I'll go ahead and put those absolute values in just so that the negative doesn't become an issue. And then negative A is a reflection over the x-axis. So for example, if I had y equals negative b to the x power, that would take my original function that would go like that, and it will actually take it and flip it upside down like this. KH, oh, I said okay, and then just said K, and that could be confusing because I'm talking about H. H is the horizontal, I can't spell obviously, horizontal shift, left or right. So like for example, if we had y equals b to the x minus 3, that would go right 3. And would look something like, take that point there, 1, 2, 3. It's rough. Kind of want to redo it. So let's say our original graph is right here. And we're moving it right 3. So it'll be like there instead, because it moved to the right 3. All right, last one is K, which moves it up or down. I spelled vertical wrong, didn't I? Call shifts up or down. So for example, if we have y equals b to the x, and then we add a 2 out here, then that's going to shift our graph up 2. That's also going to move our asymptote. I should have done that as a dotted line. So many things I want to look differently than how I first start them, and then I'm like, oops, let's do that different. Okay, so that's going to change our asymptote. And move it so that it's at y equals k. So in this case, it would be asymptote at y equals 2 instead of at 0. And of course, that moved our y-intercept so that it's at a point 0, 3 instead of 0, 1 because it went up 2. Okay, let's look at this graph together. I'm going to start by just graphing the basic graph we started with on the very first page today. So that gives us a point at 1/2, at 1, at 2, and at 4. I'm going to avoid actually connecting those right now. I guess I could just with a highlighter. I just want to be able to see the points underneath because that's more important to me. But my smart notebook file is going slowly. So I'm not sure that was a good idea to change to a highlighter. Ah, there we go. So here it is. Right? So then let's describe what's going to happen to it. See if it doesn't like going back to being a pen or not. Okay, describe each transformation. So we have, this is going to be a growth function. We're going to move left 1 because of that. And it's going to move down 3 because of that. Okay, we're going to list domain, range, asymptote, and the intercept. So domain is actually going to stay as all real numbers. That won't change. The range, instead of going from 0 to infinity, it's going down 3. So it's going to go from -3 to infinity instead. And our asymptote, remember, is that k value. So asymptote at y equals -3. And then the intercept that normally is at 0, 1 is going to move down 3. So 0, 1 to subtracting 3 would be at 0, -2. It's kind of helpful when you do these if you just take the points that you put in the first graph and just move them. So I've got this point at -1, 1/2. So the point at -1, 1/2 is going to move left 1 down 3. And then I have a point at 0, 1, which I'm going to move left 1 down 3. And then I have a point, oh, that might change this intercept. We need to think about that for a minute because of the moving left 1, we're not just moving down 3. It doesn't change the asymptote. The asymptote still is just going to be down 3. The intercept might be different than I thought. Okay, so then we're going to take this point at 1, 2 and move it left 1, down 3. See, aha, that's our intercept right there instead. So I messed that up. The intercept is actually going to be at 0, -1, and that's not because the intercept moved to 0, -1. That's because a different point moved to 0, -1, and it happens to be a new intercept. Okay, and then lastly, we have this point at 2, 4. So that point's going to go left 1 and down 3. Now we have a new graph to connect. It would be good, though, to have our asymptote in there. I'm going to go do the asymptote like this. So our asymptote, remember, is at -3. And highlighter, let's see if the highlighter will cooperate this time. It does not like switching to the highlighter. It takes a second. Maybe I won't worry about it. Now I've frozen it up. There we go. So my highlighter is going to go approximately there. You can see how my graph has moved left 1 and down